Okay, so we have lesson 3, trigonometric ratios. So this is another long lesson, but it's really a review of what you would have done last year, except now we need to do everything in radians as well. Excuse me. So if we have a triangle here, we know we have our angle theta, sine theta. We know sine, SOHCAHTOA, sine is opposite over hypotenuse. Cosine, cosine is adjacent over hypotenuse. And tan is opposite over adjacent. So we should all be pretty comfortable with that. These ratios are what we call our primary trigonometric ratios and can be remembered by the acronym SOHCAHTOA. We then have what we call reciprocal trigonometric ratios. So that is the reciprocal of the primary trigonometric ratios. Now these are on your formula sheet just like they're written here. So cosecant is 1 over sine, and it is the reciprocal of sine. So this would be hypotenuse over the opposite. Secant is the reciprocal of cosine, so this would be the hypotenuse over the adjacent. Cotangent is the reciprocal of tangent, so this would be the adjacent side over the opposite side. So these are on your formula sheet, so you don't really have to memorize them. One way people usually remember them, though, is cosecant sine, secant cosine. There's only one word in the pair that has the co prefix in it, and the other one doesn't. So cosecant goes with sine, secant goes with cosine. Okay, so now that we're talking about this on a coordinate grid, we don't really use the words opposite, adjacent, and hypotenuse anymore. We build a triangle out of it. So when we build this triangle, we labeled this side, which was our adjacent side, x, because it is the x value. If we pick this point here, this point would be x comma y. So the adjacent side is the x-coordinate, the opposite side is the y-coordinate, and the radius is the hypotenuse. So what is our equation then for our sine of theta? Well, sine's opposite over hypotenuse, so in this triangle it would be y over r. Cosecant is just the reciprocal of that, so r over y. Cos is adjacent over hypotenuse, that would be x over the radius. Secant is the reciprocal of that. Tan is opposite over adjacent, so that would be y over x, and the reciprocal, cotan, would be x over y. So the workbook here says you should memorize these. I think as long as you can build the triangle and know where it's coming from, it's not something that needs to be memorized. It should be fairly obvious. So determining the sign of the trigonometric ratio. So in quadrant 1, draw the rotational angle theta in standard position and complete the table. So here is our rotation angle. Sine is y over r. So r, no matter where we go, is always going to be a positive value. Our x and y values can be positive or negative depending on what quadrant we're in. So in quadrant 1, our x is positive and our y is positive. That's true for any term. Okay, so then our cosine here would be our adjacent side, so x over our hypotenuse r. Both of those are positive in quadrant 1, so cosine is also positive. Tan, same thing. Opposite over adjacent, so it's going to be y over x. Both are positive here. Whoops. Plus over plus, so they're positive. Now, you probably remember from last year we had a rule that tells us where these are positive, and you'll notice that these will start to fit that pretty quick here. So the reason x and y are both positive here, again, if we look at this point, that point has a positive x-coordinate and a positive y-coordinate. So that's why we're saying those side lengths there are positive. So when we move into quadrant 2, we now know that this x value must be negative, but the y value is still positive. So when we look at our ratios, starting with sine, okay, y over r, well, y is positive, the radius is always positive, sine must be positive. Cosine, x over r, well, we know that x must have a negative x value because we've moved to the left. That is a negative x value on our coordinate plane. So it's negative divided by a positive. So this cosine must have a negative value. Excuse me. Tan y over x, well, y is positive, but x is negative, so tan must be negative in quadrant 2. Quadrant 3, in quadrant 3 now, both x and y are negative. We've moved left and we've moved down to get to that point. So both x and y are negative. The radius is always positive. Here, though, for tan, we have a negative divided by a negative, so tangent is positive here, and sine and cosine are negative. In the last quadrant, so our ratios stay the same. This is y over r, this is x over r, this is y over x. Now, x is positive, but y is negative, because to get to this point, we've gone right and then down. So that's a positive x value, a negative y value. The radius is always positive, so sine must be negative here. X is positive, the radius is positive, so cosine must be positive. Y is negative, x is positive, so tan must be negative. So cosine is positive in quadrant 4. All of them are positive in quadrant 1. Sine is positive in quadrant 2. Tan is positive in quadrant 3. This is sometimes referred to as the cast rule, which is a little bit silly because then it's tempting to start things in quadrant 1. So here they've come up with a different one called add sugar to coffee to remember where things are positive. So we'll fill this in here. Since we're looking at the reciprocal of the ratios as well, wherever sine is positive, it also tells us cosecant will be positive. So the sine and cosecant ratios are positive in 1 and 2, because if something's positive, its reciprocal will also be positive. Cosine and secant is positive in 1 and 4. Tangent and cotangent are positive in 1 and 3. Sine and cosecant are negative in 3 and 4. Cosine and secant are negative in 2 and 3. And tan and cotan are negative in 2 and 4. So, determine without technology whether the given trigonometric ratios are positive or negative. So really, in order to do this, all we need to do is figure out where, in what quadrant we end up in. So sine of 280, well, where is 280 degrees? Well, that's 180, 270, 280. It's somewhere here. That is in quadrant 4. Well, there's a C in quadrant 4 there, add sugar to coffee. That tells us that only cosine is positive in quadrant 4. We were asked about the sine of positive 280, and it must be negative. B, 7 pi over 6. And we're looking for the tan of 7 pi over 6. Well, this arm here would be 6 pi over 6. So 7 pi over 6 must be here. In this quadrant, tan is positive, so this is positive. Cos of 10 pi over 3. Okay, well, let's think about this. If we're working in pi over 3s, this is 3 pi over 3. We'd get to here. A full rotation would be 6 pi over 3. Back here would now be 9 pi over 3. So 10 pi over 3 must be in this quadrant. In quadrant 3, only tan is positive, so cosine must be negative. Cosecant negative 225. So now we need to go the opposite direction. Negative 225. Well, this is negative 180. It must be somewhere in here is negative 225. But now we just keep the quadrants the same. So this is in quadrant 2. Sine is positive in quadrant 2. That means its reciprocal is also positive, so cosecant must be positive. Cotan of negative 13 pi over 6. Okay, well, if we start here, this would be negative 6 pi over 6. A full rotation would be negative 12 pi over 6. So we must be a little bit further and end up in this quadrant. So quadrant 4, is where cosine is positive. That means tangent must be negative, and if tangent is negative, cotan is also negative. 1,000 degrees, well, as soon as it's in degrees, it seems a little bit simpler. So 1,000 degrees, we need to do a few full rotations. And we stop a little bit short. 1 full rotation, 2 full rotations. We end up here. This is 1,000 degrees in quadrant 4. Cosine is positive in quadrant 4. If cosine is positive, that means secant is positive. Now, our calculators are pretty smart and can, of course, help us with this. So most calculators have the ability to calculate values of sine, cosine, and tangent ratios in degrees and radians. To calculate the value of the reciprocal trigonometric ratios, we can calculate the reciprocal. Now, your calculators have that as an option. I have to look into it, though. That might be something that is locked out in the press to test mode, so I'll get back to you on that. But it's pretty simple to go 1 divided by sine of the value. It is important, though, if you are using radians as your input, you do need to change your calculator to radian mode, and I'll show you in class how to do that. And then if you're working in degrees, make sure you change it back to degrees. So using a calculator to 4 decimal places, so we're just punching in these values here. So there's not much to say, I'll just put the answers up here. So sine of 280 would be negative 0.9848. Tan of 7 pi over 6. Make sure you're in radian mode. If you are in degree mode, it'll still give you an answer, but it will be nowhere close to the right answer. Cos of 10 pi over 3 is negative 0.5. Sine of 90. Notice how there is no degree sign here. So this is 90 radians. I've never seen a question where they try and trick you with that on the diploma exam, but it is in your workbook here. There's no degree sign, so we have to assume it's in radian, so you need to be in radian mode. E, cosecant of negative 225. So you could just type in 1 divided by the sine of negative 225. And this gives you 1.4142. Cotangent, again, you could type in here in radian mode 1 divided by negative 13 pi over 6. And you'd get the value negative 1.7321. Going back to degree mode, secant of 1,000, you could type in 1 over cos of 1,000, and you would get 5.7588. So all these signs would match what we came up with in the last example. So expressing trigonometric ratios in terms of a reference angle, the trigonometric ratios for any angle are either the trigonometric ratios of the reference angle or the negative of the trigonometric ratios of that reference angle. So use the following procedure. Determine the sine of the ratio, determine the measure of the reference angle, and then put your answers together. So to write cos of 11 pi over 4 as the cosine of an acute angle, use the above procedure. We have the sine is negative, the reference angle is 3 pi over 8, so cos of 11 pi over 8 equals negative 3 pi over 8. And you can verify that on your calculator. This is the most important when we're asked to do things as exact values and not just plugging things into the calculator. So example 4. What happened here? Okay, example 4. Rewrite as the same trigonometric function of an acute angle. So cos of 7 pi over 4. Okay, well, if I'm finding 7 pi over 4, we know that this is 4 pi over 4. A full rotation would be 8 pi over 4, because that's 2 pi. So 7 pi over 4 would be here. And we have a reference angle of pi over 4. Cosine is positive here. So therefore, I know that the cos of 7 pi over 4 is equal to the cos of pi over 4. So obviously, if you're not asked to answer as an exact value, you can just punch cos of 7 pi over 4 into your calculator in radian mode. It's going to give you an answer which would be the same as this answer of cos pi over 4. It becomes much more important when you're asked to find exact values, and we don't have 7 pi over 4 as a special triangle. So unless you want to memorize everything in the unit circle, it's good to be able to write it as a reference angle, and then you can use your special triangles, which you really should remember. Cotan of negative 100. So where is negative 100? Well, here would be negative 90. So here is negative 100, giving a reference angle here of 80 degrees. While in this quadrant, tangent is positive, which means cotan is positive. So cotan of negative 100 is simply equal to the cotan of 80 degrees. Lastly, sine of 11 pi over 2. Well, where does 11 pi over 2 end up? Well, this is 0 pi over 2, 1 pi over 2, 2, 3, 4 pi over 2, 5, 6, 7, 8, 9, 10, 11. So we end up all the way down here. This has a reference angle of 90 degrees. No matter which way you go to the axis, it has a reference angle of 90 degrees. But you'll notice that in this whole bottom section, sine is negative. So whether you think of it in this quadrant or this quadrant, sine would be negative. So therefore, the sine of 11 pi over 2 is equal to the negative sine of the reference angle, which is pi over 2, or 90 degrees. Next question, determining trigonometric ratios from a point on a terminal arm. So you probably saw this last year, but we'll do the few examples as review. The point negative 15,8 lies on the terminal arm of a rotation angle theta in standard position. Mark the angle. So the rotational angle is here. This is our rotational angle. Calculate the exact length of OP. So it tells us that this point is negative 15,8. So if I want to think of this as a triangle, we always connect our triangles to the x-axis. Our x value is this distance down here. I'm going to use positive 15 because I'm now talking about length of a triangle. And this length must be 8. So to calculate the exact length of O to P, all I need to do is Pythagorean theorem. So an O to P is the same as the radius, so I can put r squared is 15 squared plus 8 squared. Whether you use negative or positive 15 here doesn't matter. As long as you're squaring it, it's going to end up positive. So we can all do Pythagorean theorem. This gives us the fact that r is 17. So use x equals negative 15, y equals 8, and r from b to determine the exact values of the primary and reciprocal trigonometric ratios for the angle. Okay, so sine of the angle. Well, we know that sine is equal to opposite over hypotenuse. So our hypotenuse we just calculated to 17. The opposite angle, opposite side would be 8. So even though this is the angle we're working with, we can always refer to this as our reference angle here. That's what we just learned in the example above. We do need to watch our signs here. In this quadrant, sine is positive. So sine theta is 8 over 17. Cosecant is just the reciprocal of that, and it's also positive. Cos, well, we know cosine is adjacent over hypotenuse, so adjacent in this case is 15. Remember though, we're in quadrant 2, where cosine is negative, so we can write this as negative 15 over 17. Secant is then just the reciprocal of this. Tan is opposite over adjacent, so the opposite side here is 8. The adjacent side would be the 15. Tangent is negative in this quadrant, so we're going to put a negative sign there. Cotan is just the reciprocal. Using one trigonometric ratio to determine the other ones. So if cotan of A is root 5 over 2 and sine A is negative, complete the following procedure to determine exact values with rational denominators for cosecant and secant. So again, you should have done something like this last year, but we'll do that review. Since the cotangent ratio is positive, so it tells us cotangent is positive and sine is negative, it tells us we must be in quadrant 3. So we do need two pieces of information. If we just knew that cotangent was positive, we wouldn't know whether we were in quadrant 1 or quadrant 3. Since cotan of A is root 5 over 2, So now this is the reciprocal. So instead of opposite over adjacent, it tells us our adjacent side is 5, our opposite side is 2. So if we're drawing this in a diagram, I'm always going to make a triangle with the x-axis. This is my reference angle. I now know that the adjacent side is root 5 and the opposite side is 2. What this also tells me is that this point here is negative root 5 over 2. Sorry, negative root 5 comma 2. Excuse me. So use x squared plus y squared equals r squared to determine the value of r, and then we'll determine all the ratios. So it's very simple to determine your hypotenuse now. It's just root 5 squared plus 2 squared equals your radius squared. And you'll get that your radius is 3. So now we need to determine the rest of the ratios. Oh, sorry, we just need to do cosecant and secant. So remember, cosecant is the reciprocal of sine. So cosecant is hypotenuse over opposite. Well, our hypotenuse here is 3. The opposite side is 2, so that's just 3 over 2. In this quadrant, though, we know that sine is negative, so cosecant will be negative, so this is negative 3 over 2. Secant A is the reciprocal of cosine, so this would then be a hypotenuse over adjacent. It'll also be negative in this quadrant. So the adjacent side is root 5, the hypotenuse is 3. It did say that we wanted rational denominators, so now we should multiply top and bottom here by root 5. This gives me negative 3 root 5 over 5 as my exact value.